In this video, we're going to talk about radicals. So let's start off with a definition. A squared is equal to b is the principal square root of b such that a is equal to the square root of b for b greater than or equal to 0. Now, there's a couple of parts that we need to know. The value that is under the radical here is what is called the radicand. This symbol is what is called the radical. And the number that appears here is what is called the index. Now, if you don't see a number there, you assume it is 2 because it's a square root. So in other words, this would be exactly the same as this. But I will choose not to write the 2 down and write it as just the square root of b here. Okay, so let's simplify each expression. Well, here I have the square root of 36. So what value times the same value gets me to 36? Well, that answer is 6. So the square root of 36 is 6. The square root of 49 over 100. What value times the same value gets me to 49 over 100? Well, that is 7/10. 7 times 7 is 49. 10 times 10 is 100. Now, the square root of negative 36. Well, if I do 6 times 6, that's a positive 36. That does not work. And if I do a negative 6 times a negative 6, that is also a positive 36. So this is not a real number, because I cannot take a number times the exact same number to get negative 36. And then the square root of 0 is 0 because 0 times 0 is 0. All right, so a cubed is equal to b is the principal cube root of b such that a is equal to the cube root of b. And then I can write this in general. A to the n equal to b is the principal nth root of b such that a is equal to the nth root of b. Okay, so then let's simplify. So the cube root of 1,000. Well, 10 times 10 is 100 times 10 is 1,000. So the cube root of 1,000 is 10. Cube root of negative 27. Well, negative 3 times negative 3 is 9. Times negative 3 is negative 27. So here we have negative 3. The fourth root of 81. Well, that's 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is 3. Now, the fourth root of negative 81. Well, again, if I take 3 to the fourth power, that is positive 81. And if I take negative 3, in parentheses, and take it to the fourth power, that is also positive 81. So there's no number I can multiply by itself 4 times to get me to negative 81. This is not a real number. Now, in both instances, what have we noticed when we did not have a real number? We had the index being even, and the number inside the radicand is negative. So, in general, if the index is even, then the radicand must be greater than or equal to 0 to be a real number. If the index is odd, then the radicand can be any real number. Okay, so now I want to simplify where there are variables under the radical. So let's take a look at the square root of 144, s to the fourth, and t to the sixth. Well, the square root of 144 is 12, because 12 times 12 is 144. So what value times the same value gets me to s to the fourth? Well, that is s squared, because s squared times s squared. Remember, when you multiply exponents, you add the powers. That's 2 plus 2 is 4. T to the sixth. What value do I multiply by itself to get to t to the sixth? Well, that's t cubed, because t cubed times t cubed is the same thing as t to the 3 plus 3, which is t to the sixth power. Okay, let's take a look at a cube root then. Well, a cube root of 8, 2 times 2 times 2 is 8. And then what value can I multiply by itself 3 times to get to r cubed? Well, that's r, because r times r times r is r cubed. All right, let's take a look at a fifth root. Well, the fifth root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 32. What value do I multiply by itself 5 times to get r to the 10th? Well, that is r squared, because r squared times r squared times r squared times r squared times r squared is the same thing as r to the 10th. Okay, let's take a look at these next two examples then. So I'm going to take the square root of 81 and square it. Well, order of operations tells me I'm going to take simplify what's inside the parentheses first. Well, the square root of 81 is 9, because 9 times 9 is 81. I now take 9 squared, which is equal to 81. Well, my answer is exactly the same thing as the number under the radical. Let's take a look at this example. So again, I'm going to go inside the parentheses first. Well, the cube root of negative 27, that's negative 3. And when I take negative 3 and cube it, that is negative 27, because negative 3 times negative 3 is 9, times negative 3 is negative 27. And again, notice my final answer is what is under the radicand. So in general, the nth root of a taken to the nth power is equal to a, provided that the nth root of a is a real number. Okay, let's take a look at a few other examples then. So let's take a look at the square root of 6 squared. Well, I'm going to simplify 6 squared, that's 36. And the square root of 36 is 6. Okay, let's take a look now at the cube root of 10 cubed. Well, 10 cubed is 10 times 10, which is 100, times 10 is 1,000. And the cube root of 1,000 is 10, because 10 times 10 is 100, times 10 is 1,000. Now, let's take a look then at the square root of negative 4 squared. Well, negative 4, the quantity squared, is 16, and the square root of 16 is 4. So notice the answer is not exactly the same. It's the opposite of what was inside the parentheses under the radical. All right, so then let's take a look at this example. So again, I'll simplify what's under the radical. Negative 5 cubed is negative 125. And then the cube root of negative 125 is negative 5, because negative 5 times negative 5 times negative 5 is a negative 125. So there's two different scenarios that's happening here. So in general, simplifying the nth root of a to the n, for any real number a, if n is an even integer, then the nth root of a to the n is equal to the absolute value of a. Now again, let me show you the example where this applies. This third example, again, this answer is not negative 4, it is the absolute value of negative 4, which is 4. And if it's positive, the absolute value of 6 ends up being 6. Now, if n is an odd integer, then the nth root of a to the n is just equal to a. So let me show you above. This is an odd index. It ended up being 10 cubed. Our answer was 10. When it was negative, again, an odd index, notice our answer was exactly the same as what was in the parentheses here. So the only other thing I want to show is this. So I'm going to write the following. All right, so we've got the square root of x minus 4, the quantity squared. Because the index is even, so I know my answer is going to be x minus 4, but I want to make sure to put absolute value bars around that to guarantee that my answer is going to be positive. When my index is odd, I don't need to worry about that. All I need to do for this case is to write x minus 7, and we're done here.